Rockfill, also known as rock embankment construction, is a method that utilizes rocks generated from earthwork operations to build structures such as embankments, retaining walls, and road embankments. This technique is widely used in civil engineering due to its efficiency and cost-effectiveness. However, to ensure the stability and durability of these structures, it is crucial to follow specific guidelines during both material selection and construction. In this video, we'll explore the essential considerations for rock fill construction, from choosing the right materials to managing drainage and ensuring safety on site. Primary purpose of rock fill construction is to make use of surplus rocks from excavation, turning what would otherwise be waste into valuable building material. This approach not only reduces environmental impact, but also helps in constructing robust structures like embankments and retaining walls. By carefully selecting and placing these rocks, engineers can create stable foundations that support roads and other infrastructure. The process requires attention to detail, especially in terms of material quality and placement methods, to ensure the long-term performance of the finished structure. Selecting the right materials is a critical first step in rock fill construction. The rocks used must meet specific requirements to ensure the stability of the structure. This includes controlling the maximum particle size and ensuring the rocks have sufficient strength. Additionally, rocks that contain harmful substances or are highly weathered should be avoided. Proper material selection not only improves the quality of the finished structure but also minimizes the risk of future problems such as settlement or instability. One of the key requirements in material selection is limiting the maximum particle size of the rocks. For most rock fill applications, the largest rock should not exceed 30 centimeters in diameter. This restriction helps ensure that the rocks can be compacted effectively and that there are no large voids within the fill. Additionally, the finished surface of the subgrade should not have rocks larger than 60 centimeters. These limitations are essential for achieving a uniform and stable structure. Rocks chosen for fill must be strong and resistant to weathering. Using rocks that are easily broken down by wind, water, or temperature changes can compromise the stability of the structure. Therefore, it's important to select rocks that have been tested for strength and durability. This ensures that the fill will maintain its integrity over time, even under heavy loads or in harsh environmental conditions. It's essential to avoid using rocks that contain harmful substances. These can include rocks with high levels of contaminants or those that may react negatively with the environment. Using such materials can lead to pollution, structural weakness, or even health hazards for workers in nearby communities. Always conduct thorough testing to ensure that all materials used are safe and suitable for construction. Rock fill construction is typically carried out in layers. Each layer of rock is spread evenly and compacted before the next layer is added. This method helps to ensure that the fill is stable and that there are no weak spots within the structure. The thickness of each layer should not exceed 60 centimeters, and for embankment fill, each layer should be no more than 30 centimeters thick. Layered construction is key to achieving a strong and reliable structure. Compaction is a crucial part of rock fill construction. To achieve optimal density and stability, a three-stage compaction process is used. The first stage involves using a sheepfoot roller or tamping equipment, followed by a second stage with a vibrating roller, and finally a third stage with a non-vibrating roller. Each stage serves a specific purpose, ensuring that the rocks are tightly packed and that the fill is free of voids. This process greatly enhances the strength and durability of the finished structure. In placing each layer of rock, it's important to ensure that the surface is as flat and even as possible. This helps with effective compaction and prevents uneven settlement later on. Careful leveling also makes it easier to install drainage facilities and other structural elements. By maintaining a smooth surface throughout the construction process, you can achieve a more stable and long-lasting structure. Proper drainage is essential in rock fill construction to prevent water from accumulating within the structure. Drainage facilities such as pipes and filter layers should be installed to allow water to escape. This not only protects the structure from water damage but also helps maintain its stability over time. The placement and spacing of these facilities should be carefully planned based on site conditions and the expected flow of water. Further enhance drainage, it's important to use materials with good permeability in the fill. These materials allow water to pass through easily, preventing the buildup of groundwater and reducing the risk of structural damage. Selecting the right materials for drainage layers is just as important as choosing the main fill material. This step helps to control groundwater levels and maintain the integrity of the structure. Effective material management is vital for successful rock fill construction. This involves not only selecting the right rocks but also conducting tests to ensure they meet the required standards. Particle size distribution and strength tests should be performed regularly. By maintaining strict control over the materials used, you can prevent issues such as weak spots or contamination, ensuring a high-quality finished structure. Testing the particle size distribution of the rocks is a fundamental part of quality control. This ensures that the fill material is consistent and meets the specified requirements. Regular testing helps to identify any deviations early, allowing for corrective action before construction progresses too far. Consistent particle size distribution contributes to better compaction and overall structural stability. Strength testing is another critical aspect of material management. By conducting tests such as uniaxial compression or point load tests, engineers can verify that the rocks have the necessary strength to support the structure. Weak or brittle rocks should be excluded from the fill to prevent future failures. Regular strength testing is a proactive way to ensure the long-term safety and durability of the construction. Managing the compaction process is essential for achieving the desired density and stability in rock fill construction. The speed of the roller should not exceed 4 km/h, and the vibration frequency should be between 1,000 and 3,000 RPM. These parameters are carefully chosen to optimize compaction without damaging the rocks or the underlying layers. Proper compaction management helps to eliminate voids and create a solid, stable structure. Drainage management is a key factor in maintaining the stability of rock fill structures. This involves not only installing drainage facilities, but also carefully selecting the materials for filter layers and ensuring proper construction. The location and spacing of drainage facilities should be reviewed and adjusted as needed to suit site conditions. Effective drainage management prevents water accumulation and reduces the risk of structural failure. Filter layer is an important component of the drainage system in rock fill construction. It prevents fine particles from clogging the drainage pipes and ensures that water can flow freely out of the structure. Selecting the right materials for the filter layer and installing it correctly are essential steps in maintaining effective drainage. Regular inspections should be carried out to check for any signs of clogging or damage. Before starting any construction work, it's important to provide thorough safety education to all workers. This includes training on the proper use of equipment, recognizing potential hazards, and following safety protocols. By ensuring that everyone on site is aware of the risks and knows how to respond in an emergency, you can significantly reduce the likelihood of accidents and injuries. Regular inspection of construction equipment is essential for maintaining a safe work environment. This includes checking for any signs of wear or damage, ensuring that all safety features are functioning, and performing routine maintenance. Well-maintained equipment not only reduces the risk of accidents but also improves the efficiency and quality of the construction process. Installing rockfall prevention facilities is a crucial safety measure in rock fill construction. These facilities help to protect workers and equipment from falling rocks, which can cause serious injuries or damage. Common prevention methods include installing barriers, nets, or fences around the work area. Regular checks should be conducted to ensure that these facilities are in good condition and functioning as intended. Controlling dust is an important part of environmental management on construction sites. Dust can not only cause health problems for workers, but also impact nearby communities and the environment. Measures such as spraying water using dust suppressants and covering materials can help to minimize dust generation. Effective dust control contributes to a safer and more pleasant work environment. Minimizing noise is another key aspect of environmental management. Construction activities can generate significant noise, which may disturb workers and nearby residents. Using quieter equipment, scheduling noisy activities during daytime hours, and installing noise barriers are effective ways to reduce noise levels. These measures help to create a more comfortable and compliant work environment. Proper treatment and disposal of wastewater is essential to prevent environmental pollution. Construction activities often generate wastewater that may contain sediments or contaminants. Implementing sedimentation tanks, filtration systems, and regular monitoring can help to ensure that wastewater is treated before being released. This protects both the environment and the reputation of the construction project. Quality control is a continuous process throughout rock fill construction. It involves regular testing of materials, monitoring construction methods, and inspecting finished work. By maintaining high standards at every stage, you can ensure that the final structure meets all safety and performance requirements. Quality control is not just about meeting specifications, it's about building structures that last. Laboratory testing is an important part of quality control in rock fill construction. Common tests include specific gravity, absorption, Lowe's-Angels abrasion, and soundness tests. These tests help to determine the physical and mechanical properties of the rocks, ensuring that they are suitable for use in construction. Laboratory testing provides valuable data that guides material selection and construction method. Specific gravity test measures the density of the rock compared to water. This information is important for calculating the weight and stability of the fill. Rocks with a higher specific gravity are generally stronger and more suitable for use in construction. Regular specific gravity testing helps to ensure that only the best materials are used. The absorption test determines how much water a rock can absorb. Rocks that absorb too much water may weaken over time, especially in wet conditions. By conducting absorption tests, engineers can identify and exclude rocks that are likely to deteriorate, ensuring the long-term durability of the structure. Lowe's-Angels abrasion test measures the resistance of rocks to wear and tear. This is especially important for rocks used in road construction, where they will be subjected to constant traffic and friction. Rocks that perform well in this test are more likely to withstand the demands of the structure and maintain their integrity over time. Soundness test evaluates the ability of rocks to resist weathering and chemical attack. Rocks that pass this test are less likely to break down or lose strength over time. This is particularly important in environments where the fill will be exposed to water or chemicals. Soundness testing helps to ensure the long-term stability of the structure. In addition to laboratory tests, field testing is conducted to assess the performance of the fill in real-world conditions. This includes plate load tests to measure bearing capacity and test embankments to evaluate compaction and stability. Field testing provides immediate feedback and allows for adjustments to be made during construction. Plate load test is used to determine the bearing capacity of the rock fill. By applying a load to a steel plate placed on the fill, engineers can measure how much the fill compresses under pressure. This information is essential for designing structures that will be built on top of the fill, ensuring they have a stable foundation. Constructing a test embankment section allows engineers to evaluate the compaction and stability of the fill before proceeding with the full project. This small-scale test helps to identify any issues with materials or construction methods, allowing for adjustments to be made early on. Successful test sections provide confidence that the main structure will perform as expected. Continuous monitoring during construction is essential for maintaining quality and safety. This includes regular inspections, testing, and documentation of all activities. By keeping detailed records and addressing any issues promptly, you can ensure that the project stays on track and meets all requirements. Accurate documentation and reporting are important for tracking progress and ensuring accountability. This includes recording test results, construction activities, and any incidents that occur on site. Good documentation practices help to identify trends, support decision-making, and provide evidence of compliance with regulations. When nonconformities are identified during construction, it's important to take immediate corrective action. This may involve removing unsuitable materials, recompacting sections, or making adjustments to construction methods. Promptly addressing issues helps to maintain quality and prevent more serious problems from developing later on. Thorough final inspection is conducted once construction is complete. This includes checking the quality of the fill, the effectiveness of drainage facilities, and the condition of safety measures. Any deficiencies should be corrected before the structure is put into use. Final inspections ensure that the project meets all standards and is ready for operation. Planning for maintenance is an important part of ensuring the long-term performance of rock fill structures. This includes scheduling regular inspections, cleaning drainage facilities, and repairing any damage that occurs over time. A proactive maintenance plan helps to extend the life of the structure and reduce the risk of unexpected failures. Protecting the environment is a key consideration in all construction projects. This includes minimizing dust and noise, treating wastewater, and preventing the spread of contaminants. By following best practices for environmental management, you can reduce the impact of construction activities and contribute to a healthier ecosystem. Ensuring the health and safety of workers is a top priority in rock fill construction. This involves providing personal protective equipment, enforcing safety protocols, and promoting a culture of safety on site. Regular training and communication help to keep everyone informed and prepared to handle potential hazards. Maintaining good relations with the local community is important for the success of any construction project. This includes communicating about construction schedules, addressing concerns about dust or noise, and ensuring that all activities comply with local regulations. Positive community relations help to build trust and support for the project. Adopting sustainable practices in rock fill construction benefits both the environment and the project. This includes recycling materials, reducing waste, and using energy-efficient equipment. Sustainable construction not only reduces costs but also demonstrates a commitment to responsible development. Innovative technologies and methods are continually improving the efficiency and quality of rock fill construction. This includes the use of advanced compaction equipment, real-time monitoring systems, and new materials. Staying up to date with the latest innovations helps to ensure that projects are completed safely, on time, and within budget. Successful rock fill construction relies on effective teamwork and communication. All members of the construction team must work together, share information, and coordinate their activities. Regular meetings and clear communication channels help to prevent misunderstandings and keep the project moving smoothly. Continuous improvement is a core principle in construction. By regularly reviewing processes, learning from past projects, and seeking feedback, teams can identify opportunities for improvement. This commitment to excellence leads to better outcomes and higher quality structures. Summary: rock fill construction is a complex process that requires careful planning, material selection, and quality control. By following best practices for material management, compaction, drainage, safety, and environmental protection, you can build structures that are safe, durable, and sustainable. Remember, attention to detail at every stage is the key to successful rock fill construction. Thank you for watching, and we hope you found these guidelines helpful for your next project.